Hi, and welcome to this lecture as part of Iolite's Python for LA-ICP-MS course about importers. Just to give you an overview, in this presentation we'll be looking at file formats and the parts that we need to be able to import our data into Iolite. We'll have a quick look at Iolite's data manager because that does a lot of the work that we'll be doing in our importer. We'll have a quick look at channel, file and sample objects. And we'll be looking at an overview of Iolite's import process so that we know where our importer fits into that process. Then we'll look at what makes up an import module, and there's three main parts to that. We'll speak about the main modules and packages that are available to importers. And I'm going to give a live example of writing an import module. And I'll keep all my mistakes in there because hopefully that will save you from making the same mistakes. And I'll show you my process for debugging and improving the importer as I go. So let's look at some of the most common data formats. This is a CSV file from an Agilent file. I've chopped out the main part here, so the middle part here, because there's 12,000 lines in this particular file. But it's called a CSV file because it's comma separated values. So each of the values are separated by a comma. And it's made up of three main parts. There's the header, or the header information, the header lines as we sometimes call it. And this is metadata. This is data about our data. We also have the main data, which you can see here, which is the actual values that were measured. And we have the footer. Not all files have a footer. Just like not all files have a header, but sometimes they do, and it's just some blank lines at the end. Sometimes it's a statement like this when it was actually printed, that type of thing, and we'll need to account for those in our import process so that our importer doesn't try to treat this like data. So what are the important parts of the header that we need? Well, we'll need to extract the start time. This is really important because Iolite needs to know where to place your data in time. And not just time, but date and time, in absolute time. So that start time is really important because quite often in our file, we just have in the data section, the elapsed time. So this is the first measurement, which has a timestamp of 0.65 seconds. The next one has a timestamp of 1.3 seconds, and so on and so forth. But we can't use that to plot our data in the overall scheme of things because it's just an elapsed time since the file started. So we need this timestamp up here to be able to place these data in context. A sample name is also good so the user can understand and contextualize where these data come from. You can show that sample name in Iolite so that you can look for it, that type of thing. So it's handy, not essential, but it is handy. And the channel names, we need to know what each of these are. In this case, it's on line 4, and the Agilent file is quite handy like that. However, there are some data files that don't have channels in them, and we'll be using that actually in our example today so that you can see how you can put them in if they're not in the header. Some other files are rich with metadata. They have things like dwell times, instrument settings, those sorts of things. And you can actually copy them across into your Iolite experiment as well. Here's another example data format, and this is actually the file that we'll be loading in this is the file we'll be using when I write the importer today. And you can see that this has a lot of lines of header. In fact, it has 58 lines of header. And these are all just instrument settings up here before we actually get into the data. However, you'll notice that there are no channel headers. We have no channel names in here at all. And this is actually a problem with this format file. It's from an older New Plasma instrument because you have to work out what each of these channels are some other way. Now, I know what they are based on this instrument, and you'd have to know some other way as well. But it's not actually included in the header information, which is actually a flaw with this data format. But there are lots of metadata here, and you can capture those if you want and carry them across into your experiment. And when we look at this, this is actually quite a common data format where we have time increasing as we go down the file, and then we have our channels as we go across. So this was a measurement this was basically a sweep across here. If it was a multi-collector, it would be the integrated time for each of the channels measured, and then it has another measurement down below and the timestamp and so on and so forth. There are files out there that have just a single column where it has say this measurement, and then underneath it'll have this measurement and then this measurement, and it'll just be a single column. And that means for if you have say 11 masses that you've measured in your experiment, you'll have 11 lines, and then you'll have another timestamp and then another 11 lines, and you'll just have to keep looping through that if you do get that sort of file format. It is a lot more work to work with, a lot harder to read as a human as well, but luckily they're reasonably rare. If we have our data in this sort of format, we can actually use an automatic CSV importer, and we'll be using the one from the Pandas package to load this sort of tabular data. The Pandas package, as Joe's already mentioned, is one of those really commonly used data science packages out there, so it's really useful to know how it does these sorts of things. So this would be a good example. Even though we're writing an importer for Iolite, you'll be able to use these skills for other tasks outside Iolite. In particular, we'll be using the Pandas function read_CSV, and I'll put a link in the notes for this week, linking to the documentation for this function. So let's have another look at Iolite's data manager. This is what you get when you type in data either into the Python console or the Python workspace, or when you're writing a module, if you type in data dot, it will access Iolite Central Data Manager. I call it Iolite Central Data Manager because it has this sort of overarching controlling function where it contains the results, it controls the channels and the reference materials and the selections and a whole bunch of other things. It's actually called the Iolite Python interface more completely. So when you go to the documentation, and there's a link down here for that, that will explain all the things that it can do. But if you think of it as the sort of the data manager or the data controller, that's a good conceptual way of thinking about it because it controls all those parts. And we'll be looking now at how we use that to create an importer. So when you import data into Iolite, there's a few things that you want to create. You want to create a file so that the user can see that a file has been loaded, and so this is what appears in this table. If you're in the files browser, there's a file object here, and it has a bunch of properties that lets the user know when the file started, when it ended, when it was loaded, how many points it was in, and so on and so forth. We'll need to create an object so that it will appear in this list, and it's actually a file metadata PyInterface object, but we'll just call it a file object for short. The documentation for the file metadata PyInterface is here at this link, but just in short, it has a file path, it has the file name, it has the file start time and end time as well. Those are the properties of the object that you can read back, but as you can see, there are actually other properties here that you can't necessarily read back at this point in the API. Now we can create an object, one of these objects, using data.create imported file metadata, and then we pass the start time, the end time, the file path, the import time, so when it was imported, the number of points that we loaded from the file, and the channel list. And just as a key for these, what each of these variables are, this one is a date time, a Python date time. This is another Python date time. This is a string, another Python date time, an integer for the number of points, and this channel list is the list of strings, that is the names of our channels. Also, while we're at it, I would like to point out that Iolite objects quite often have a dictionary of properties. You can access these by going to myfile.properties. Let's just have a quick look at a file object now. So here's an experiment that I've loaded that has a lot of files that have been loaded in, and each one of these is a file object. And if I was to open the Python console by going to Tools, Python console, or using this Control-Shift-P shortcut, and I can actually look within the console at those objects. So if I was to say data.imported, and I just hit tab there to complete this for me, and imported files, and you can see it returns a list of file metadata interface objects. You can see that it's a list because it has this comma here. So it has what it is, and then it actually tells us where it is in memory. We don't need to worry about that last part there. Now if I wanted to get one of these files, I'd just take the first one in the list. So I'd say f equals data.imported files. That's the list, and then I'll just take the first object from that list. So now f is just a single file metadata interface, and now we can actually have a look at it. We can say file f.start time, and you can see it returns a Q date time telling us when it was, so when it starts. Same thing with the end time. We can say file.file path, so it tells us where it was loaded from, where it was loaded from. And as I mentioned, most of these objects have a dictionary of properties attached with them. We can get that dictionary by going f.properties. Now you can see in this case it's actually an empty dictionary, but we can assign values to it as well by using f.setProperty. Then we give it the name of the property and the value. Let's just set it to a value of 10. And now if we look at the properties, you can see it now has this property. Now that might seem really basic, but you can actually use this to store metadata about your property, about your file that was loaded. And we'll come back to that in our example. So as I mentioned, we can collect up metadata from our file and store these in the properties of the file object using this line here. So the file object dot set property, and then the name of the property, and then the value for the property. Now I should point out that these properties will be saved with the experiment, and you can use them in your modules and in other parts of the Python interface, but there's no guarantee that these will be automatically exported by, say, Iolite's file exporter, or when you import them into the database. There's not necessarily they're not necessarily going to be carried across to those, because there's no defined set of properties here. So just so you know, you can use these in your Python modules, but that doesn't mean Iolite necessarily will use them. The same thing goes with sample objects. So just to remind you how the samples work, for each file it may contain several samples. Most of the Agilent files just contain a single sample, but things like the ICAP importer, the file can actually contain multiple samples. These are the ones that show up in this samples browser. So these can either be mass spec samples or laser log samples. We won't be talking about laser log samples today, we'll be just talking about mass spec samples. And the API for these are described in the sample metadata interface, because that's the full name of the object, even though I'll just be referring to them as a sample object. And similar to the file object, each has a file path, a file name, a start time, and an end time. And you can use these sample objects to do things like create selections. You can get out a list of start times, or a start time for it, and then split that time up. You can create other objects based on these properties as well. And we create them using this data.createFile sample metadata function, which takes the sample name, the start time, the end time, and the file path. And each of these variables, the first one is a string, the second one is a pi date time, third one's a pi date time, and the last one is also a string. Now let's have a look at channel data in Iolite, because after all, this is what we're trying to do. We're trying to create channels that then can be fed into data reduction schemes, or they can be plotted up using Iolite's visualization tools, those sorts of things. We can create selections on them, that sort of thing. This is the main thing that we'll be doing in Iolite. So let's have a look in a little bit more detail at channel objects in Iolite. Each channel is actually stored as a time series data pi interface object. We call it a channel object, or a TSD for time series data for short. And the API for that is located here, is documented here. And each time series object has a name, so describing what the channel is called, and it has a data array, which is a NumPy array, which are the actual measurements for the channel. It has a time array, which is the timestamp for each measurement, and it also has a list of properties, or sorry, a dictionary of properties, with each value having a string key. So let's have a look at one of those in Iolite. So using the same experiment, I've just gone to the channel browser so we can see our channels, and I've got my Python console open, and let's just get out the channel object for sodium-23, and we do that by, we'll call it, say, Na for sodium, and we'll say data.time series to access the time series, and we pass it the name of the time series, and now we have our sodium time series data pi interface object, or our channel object. So we can say na.name, and it will tell us what the name of the channel is. We can say na.data, and it passes us back our values within our channel, which we can see here. So the first value is 157,000, and so on. We can have a look at the time, and we can see here that this is also a list of numbers. Now when you look at this here, you might say, but isn't this a list of dates that are aligned like this? Well, actually, the way that the time data are stored are as the number of seconds since epoch. So the time for your channel objects is actually recorded as a number representing the seconds since the epoch. And that is actually just the same way as saying this number of seconds since January 1st, 1970. For a little bit more information about this, there's a link here that you can go to that explains a little bit more, but basically it's just a really large number representing how many seconds have passed since that time and date. Because it's very difficult for us as humans to work out the number of seconds that have passed for recent dates and times, we're actually going to convert our strings into a datetime object using Python's datetime.timestamp object. That will actually allow us to convert a string into a datetime object and then use that timestamp function to get the seconds out. And we'll see that in our example. For a little bit more information about this datetime library, you can follow this link here. Just so that you know, the date times in Iolite are currently not time zone aware. So obviously the number of seconds is different depending on where you are. But at the moment it just assumes that the time elapsed is all relative to your local time. And one other thing to note is that we generally put in a blank value at the end of each file, 1 millisecond after the end of the file, just to show that that's the end of that file, and so that the different files don't all join up looking like we have a continuous set of measurements. We actually put that little gap in so that you can see in the time series view where the files start and end. So just to speak a little bit more about the datetime objects, as I mentioned, there's these datetime objects that are in Python that are used to store a particular date and time. And we use them because they have a lot of convenient functions for both creating them and for transforming them into other forms. So for example, you can create one by reading in a string, and there's also a function that you can use it to create a timestamp. And when I say timestamp here, I mean this second sense epoch. In our importer, we'll read in the string, which is in our file, and we'll use that to create a datetime object, a Python datetime object, and then we'll use that datetime object to work out our second sense epoch so that we can record our measurement times in this second sense epoch. And just something to note that might catch you up sometimes or trip you up sometimes is that there are both Qt datetime objects, which are Q datetime objects, and there are also Python datetime objects. Quite often when you're in the Python interface, you'll be creating Python datetime objects, but you might get back from Iolite Q datetime objects. And if you can't work out why it's not working, then you just need to check which one you're actually working with. It might be a Q datetime instead of a Python datetime. So now that we've got that sort of background information out of the way, let's have a look at actual import modules. So just to give you a feel for how the import modules work, when Iolite starts up, you'll quite often notice that sometimes there's a little bit of a gap between when it starts and when you actually see that window that has the list of recent sessions and recent templates. At that point, Iolite's going through and loading up all the modules. All the modules that it does find are listed in the plugin manager, which Joe's already given you a quick demonstration of. Here you can enable and disable your importers and other modules. And any custom or Python import modules that you've written yourself will be loaded from the importers path. So they need to be in a particular folder so that Iolite knows where to find them and to load them when it starts up. And in particular, that folder is set in the paths under the importers section. That's where Iolite will look for import modules, custom import modules, when it starts up. And just so you know, by default, if you haven't changed your import folder path, it will be in your documents folder, in the Iolite folder, and then in that there is a plugins folder, and then there's the importers folder. So now let's have a look at what happens when Iolite imports some data, or when the user wants to import some data. So first of all, the modules are loaded at startup. Each module actually reports which file extension it can load. So can this custom importer that we've written, can it load CSV files? Can it load .txt files? Can it load, so on and so forth? And it actually tells Iolite what sort of files it can load. Then the user selects a particular file or a folder using the user interface. And then Iolite runs through all the importer modules and tests them to see if they can load that particular file. If you're loading a folder, it will actually run through all the files in that folder, and it would actually keep a list for each file which importer can be used for that file. Then once it's determined which importer can load a particular file, it actually calls that importer and it actually loads the file at that point. And then Iolite, using its internal structure, will then update everything once the import is completed. So it will do things like calculate total beam, calculate the index time, and it will update the user interface so that we'll now be able to see if any new files have been loaded and any new samples have been added, that type of thing. So where does your importer module fit into this? Well, in this part here, where the module reports what file extension it can load, it will call this function here called accepted files. So we need to have a function called accepted files. When Iolite is testing whether a particular import can load a file, it will call this function called correct format. So what this function does is it goes through and tests the file to see if it's in the format that we want. And then finally, if it has decided that this importer is the right one to load this particular file, it will call import data within that module. And that's what actually does the work of importing the data. So as I mentioned, the accepted files function just returns what file extensions it can run. The correct format function tests whether or not the format is what this importer is looking for. And it usually does this by looking at some bits of text within that file, and it either just returns a true or a false, like a boolean, saying whether or not this is the correct importer for this file. And finally, the import data, which does all the actual work of importing the data. And one of the most important parts of that, as I've already mentioned, is this add data to input function, which will actually add our channel data to Iolite's data manager. Now, there are some modules that are already available to the importers by default that you don't have to load in. These include the data manager, which is referred to as data. There's also Iolog. Now, just note that these are actually case sensitive, so this is a capital I and a capital O. And this module allows you to access Iolite's main logging interface. So in the messages that appear to the user interface, to the user, in the bottom left of Iolite's user interface, there's the messages tab. Then when you go to that, it shows you all the messages that Iolite's printed out. This is how you can access that using in your Python module. And you can do that by writing something like, say, iolog.debug, and then you could put a debug message there. You could also do iolog.error and then put your error message there. There's also an information and a warning level as well. There's also the importer module as well, because your custom Python importer is actually a subclass of Iolite's Python importer class. And when that happens, when you subclass it, you have a few functions that are automatically available to you. These are normally accessed by typing importer dot and then whatever function or variable you're trying to access. The important ones that we'll come across today is importer.filename and a few signals as well that we'll see. Now, what are signals? Well, in general, the Python code that you write can emit signals, and these are basically just messages going back to Iolite's main event loop. So Iolite has an event loop, which is just this monitor that is constantly looping over and checking for, has the user moved the mouse, has the user pressed a key, has the user clicked a button. And it's searching for these things, and when it finds them, it will execute some bit of code, or it might update the user interface, that type of thing. Now, you can link into that by emitting signals from your modules. As I mentioned, they can be used to do things like update the user interface or call other functions, potentially. They're a little bit hard to tell from what are just regular functions, because they look just like regular functions. In the importers, the relevant signals, in fact, the only signals that are really available to you, are these importer.message, which will update the message that is available which is shown to the user in the progress indicator. So this is the progress indicator that appears in the bottom right hand corner when you're running your script, and it will have the name of the module that is calling it. You don't have to set this is normally automatically set, but that's actually set in importer.task. And there's a message down here that can be updated. You can update that in your importer by calling importer.message and typing in your message. Similarly, there's also this circle that grows as we get closer to completion, with 100% being the full circle. And you can set how far around we are in our progress by using importer.progress and an integer representing from 0 to 100 how far around we are in our progress. Also, you can call importer.finished, and this is a signal that tells the rest of Iolite that the import process has finished. So Iolite will then automatically recalculate total beam and update a bunch of things to show that an import process has finished. So now let's have a little bit more of a look at the import module itself in detail. So as Joe's already mentioned, each module starts with some metadata, and this includes some fields that will be used by Iolite to understand what this module does. The important part of an import module is that it needs to be listed as an import module in the type. this will mean that it will then be treated like the other importers. So that will mean that it will be used when Iolite's testing if a file can be loaded and that type of thing. The rest is really just metadata so that you can find it and so that anybody using it knows how it works and how to get in contact with you. And now let's have a look at how to create our own importer. So I'm going to start with this template here, which we'll have as a link in the course notes, and we'll start writing one up for the file, the example file that you can also download from the course notes. Okay, so the first thing that I do when I'm writing an importer for a file is I look at several examples of the file. This is so that I can see if anything's changing between the different files. So if the format is not set between files, or if certain parts of it are changing, then I need to allow for that. Sometimes if the format is not constant enough between files, sometimes we can't even use it. That's pretty rare though, and so normally I'll be looking through it and just seeing, well, how much of it is header and what is in the headers, what is the data arranged as, and I'll also go down and have a look, just see if there's any footer. In this case here, there's just a single blank line at the end, which shouldn't be a problem. So this is of that format, the new Plasma format that I mentioned. So I already know that it doesn't have any channel names, and we'll actually have to hardwire those into our importer. This means that our importer will only work with files that happen to be in this format that measure these particular masses. So in this case, it's looking at strontium isotopes. If I was to load another file from this mass spectrometer that was looking at, for example, neodymium isotopes, I'd have to write another importer because I've hardwired the channel names. Unfortunately, that's just what has to happen with these particular files because we can't tell what the channels are called. The other thing I'll be looking at straight away is whether or not it has a decent timestamp. If it doesn't have a decent timestamp, and by decent I mean in a reasonably easily readable format and with a reasonable amount of precision, and by reasonable I mean it should at least have seconds. If it doesn't have seconds, you might still be okay, but it means that your file could be offset by up to 60 seconds. If your files are quite long and you don't have many in your session, then that might not be too much of a problem. And if you have large gaps between your files, that might not be such a problem. But if you have small gaps between your files and you can only place them within 1 minute of one another, then you might get file overlap issues. In this case, we have a decent timestamp. I'll also note anything that will help me pick out where the data actually starts. So I happen to know that these files always have this word spare text just before the data starts. So we'll look for that when we're looking through our file. All the rest up here is just metadata about the instrument settings. And in our example here, just for brevity, I won't work on that too much. The next thing I'll do is I'll actually either take out any other custom importers that I have in my importer file, importer folder. So if this is the folder that's looking in, I'll go and make sure that there either aren't any other importers there, if you have some others, just so that I know that they're not going to be interfering with one another and that there'll only be one custom importer that's being called at a time. This is especially relevant if you're writing an importer for something such as a CSV file where the two might be competing with one another. So with that, I think we're ready to start writing our importer. So I've just opened in a script editor the importer template that you can download, and I'll start off by updating this metadata at the top here. So we're going to keep the type as importer. We're going to change the name to be, well, this is a strontium isotope.run file importer. We want to keep it reasonably concise, no, not concise, we want it to be reasonably precise, because you may have a lot of importers and you want to be able to pick which one you're looking at. We could put in your name, and this is where we'd put in a decent description of our importer. And this is again so that we can work out what this particular importer is. Right? So if I just wrote a new plasma.run file importer, then somebody else might come along and say, well, why is it not working for my neodymium isotopes? And that's because it's written specifically for strontium isotopes. So we should put that in there. So we'll put in strontium isotope.run file importer. If you'd publish this somewhere, you could put in a reference there, or you could put in a website that people could go to find out more about it. You can keep track of the version number if you want. And this is what you should put in. You should put in a contact email or a web page that people can go to if they want to contact you about it. If you don't, you can just leave it blank. We quite often put in support@iolite-software.com, which is the main Iolite support email address, if you didn't already know that. So now we have our metadata set, and we can import some packages here. So we're importing NumPy, Pandas, the regular expressions library, and the datetime package as well. And those will be all that we'll need in this case for our importer, but you can import anything that you have a package for at this point. Now we can see that there are the three main functions that I described before: the accepted files, the correct format, and the import data functions. So I'm actually going to change this to .run. Oops. I'm going to change this to .run because, as we can see over here, this is our file format, .run. And at this point, I'm going to go to Iolite, and I should have restarted Iolite after I check my path and everything. And now I'm going to check my plugins. So I'm going to see if we have a strontium isotopes.run file importer. And so here we have our information here. And so it looks like it's all good to go. And one of the other ways that I'll know that it's working is if I click import file and click here, it has .run as one of our file types that we can run. This means that, so this is not in Iolite's default list, so that means that it is reading our module, and so we're already working on our module, and it's already been read by Iolite. So we've completed the accepted files function. Now we need to move on to the correct format function. So this is the one that quickly reads through the file data and returns either a true or a false, depending on whether or not it's the type of file that it can load. So I think the easiest way to work this out first is we want to return false if the file doesn't end with .run. That way we don't even need to read the file contents, and it will make it a lot quicker when our import process starts. So we can just say if not importer dot file name dot ends with, so this will just look at the end of our importer file name. So as I mentioned earlier, this importer gives us access to the import class, and this file name is one of those variables that's set by Iolite, and it will contain the name of the file when this function runs. So we can say if it doesn't run, so if not ends in run, return false. So if the file doesn't run, it will return false. Now if we get past this, just to test this, we're going to actually just leave ourselves a little debug message here. So I'm going to access Iolite's messaging interface by going ilog, whoops, getting the cases right, ilog.debug, and I'm just going to say I'm going to use an F string, so it starts with F, and we'll say importer called on, and then I'm going to put in curly braces our file name. So importer.file name. Now this F string, what it does is it will convert anything in curly braces to its actual value when it comes time to print out this statement. So if we get past this test here, this ends with runs, then this will run. So this will print. So let's give that a shot now in Iolite. So we go back here and we say import file. We're going to click on our test data file, and it said that it was unable to find a suitable importer. That's okay, because we haven't returned true from this function yet. We haven't actually returned true here. But what we can see is if we go here, and I've actually said, it actually says that there is no attribute called ends with for strings. I'm actually just going to clear all these messages. So this means this should actually be ends with, not ends with. So that should be ends with. Okay, and I just saved that, I think. Oops. Save that, and I just clear these messages each time. Normally you don't want to clear these messages when you're actually doing the experiment, because you want to keep track of everything that's happened in your experiment. But when you're debugging something in Iolite and you're printing messages over and over again, it can help to clear it so that you know that any messages you're seeing are from the last time that it ran. So we'll go back to our data, click import file, click open. It's telling us that it couldn't find something, again, because we still aren't returning true. And I'm still getting that ends with incorrect format. So I still haven't fixed that. Okay, so I fixed that now. And so we'll go back and we'll try and run it again. And if we get past this line, we'll get to the debug statement calling what file name that we've tried to load. So if we go back, file import, try to import the file. Still saying it hasn't found a suitable importer. That's because we haven't returned true yet. But we can see here that importer was called and it's printed out our file name. So that's actually this string here. So we've got to this point here, that's working. Now we can actually test to see if it is an actual strontium isotopes file. So we can do that by going in here, and we'll have a look for the bit that identifies this as a strontium file, and that's this laser_strontium.nrf part here. So we're going to do a little regex to see if we can find that. So we'll get rid of this line here, and we'll say nrf_regex. This will be our regular expression, and we're going to say laser_strontium, and I could just put a dot, but dots match everything in regular expression, so I'm going to escape it with a slash and say nrf, and if it has that in the file, then we want to return true. So we'll say with open, and we'll open our file as f, and we'll see if we can find a match for that. So we'll use re.search, and we're searching for our nrf regex in our file after reading in all the data, and we're going to tell it that it's a multi-line search. So we're going to use this flag here, multi-line. And if that search returns a match, we'll say that yes, this is the file we're looking for. So if match, so match will equal false, or it'll equal false if it hasn't found a match for our regex. But if it does find one, that will be true, and we can return true to say that our importer can load this file. So let's go back here and we'll clear this, and we'll import the file again. And you can see that this time we don't get an error message saying that no files could be opened, and we get a progress indicator, and we get this message saying that we're using a Python importer to import this file. So that's good, but as you can see, nothing's been loaded yet, no samples, no files, and that's because we haven't actually written anything here in our import data function. So the first thing that I would do when I start writing this import data function is I would look for the timestamp. That's one of the most tricky bits, but it's also one of the more important bits as well. So what I'm going to do is I'm going to look for that timestamp within my file, and one of the tools I use for that is an online tool for constructing regular expressions. And let's have a look at that now. So let's now look at extracting this date timestamp using a regular expression. So what I do, and you don't have to do it this way, this is just a tool that I use, is I copy some of the text around the timestamp and copy that, and I put it in this website. So the website is called regex101.com, and it's just an online regular expression tester. I find it really handy. And what you can do is you can paste in a test string. So this is a string that's going to be searched, and up here you can type in some regular expression and it will show you all the matches for it. So if I type in digit or multiple digits, it will show me every time it's found a digit. Now a quick way of finding the timestamp, because this is the only part that we want to find, is we can copy that and paste it in here. And the first thing to do is say, oh, we've got a pattern error, and it highlights the pattern error for you. So that's why this tool is really handy. And if I hover over that, it says you need to escape these with backslashes. So I'll put in backslashes there, and it now is showing us what matches. So that's great. It's matching the whole thing. Then I start by just replacing any digits with /d and how many digits I'm looking for. So in this case, I'm looking for 2 digits here. I'm looking for 2 digits here and 4 digits here, 2 digits here, and so forth. Okay, so that now matches that. And it's now doesn't matter what the date would be or what the time would be, it will still match it. So to test that, I actually just now copy this out and paste it a few times. Oops, and each one in a new line, just so that we can be sure that it's working. And what I'll do is I'll then make some variations on that. So what if this was, say 2021, that still matches, that's great. What if this was 13, that still matches. What if this was AM instead of PM? Okay, so we can see that that doesn't match, and that's because in my regular expression up here, it's only looking for the exact match for PM. So what I can do there is I can turn that into a class and give it some options. So now it will look for either AM or PM there. Okay, so that seems to be a reasonably comprehensive regex that will match any timestamp like this. You can see that if the year was actually just without the leading 2 digits, then that wouldn't match. So we have to be we have to assume that that's not going to happen in our file. So now we can actually copy that back to our script. So we can say we're going to call it our date time regex, and that is equal to this. Now when we paste this in, those quote marks are going to confuse it and think that we're actually ending our quote. So we'll enclose that and we'll escape them. So I'm escaping this first one because remember, in our file we actually have quote marks in this line, and we need to tell it that this is actually a character we're looking for, not the end of our string here. So if I escape that one, and there's another one to escape at the end, and then I actually want to close my quotes. Okay, so that's our regular expression sorted. Now we need to read in our data and see if we can find a match for that. So the way I do that is I would actually, to start off with, I'm just going to read in our data and store it as a variable. So let's put a comment saying that's what we're doing as well. Comments are always good. So read in file data. So we're going to say with open importer dot file name as f file data equals f dot read, and that will read everything. Okay, so that's now in a file in a variable called file data. So now we can do our test again like we did before. So we say match equals re.search, and we're going to search for our dt regex in file data. That's our variable containing all our file data, and we're going to tell it again that this is a multi-line search. And what we can do here is we can say if not match, so if we can't find our date time format, then we can't actually go any further. The importer needs to stop because we're not going to read any more data because we can't locate this file within time. So we're actually just going to bomb out at this point. So what we'll do is we'll say iolog.error. So we're going to send Iolite an error message, and we're going to say could not find the date or time or date timestamp in file. That would be what the user sees in the messages. Then we're also going to add a message for the progress indicator. So we'll do that with message and say import error timestamp not found. We won't put like a super detailed explanation here because it just flashes up very briefly for the user, but at least they'll be able to see that there was some sort of error. We'll also put in some a progress indicator, so saying that it's not still waiting, it's not still working. We're going to say that it has finished, so we're going to set that to 100, and we're also going to tell Iolite that the importer has finished at this point. So this only happens if we can't find a match. If we do find a match, we'll actually just print that out. So let's do print match dot, and to get the match text, we can just use this group, and we'll tell it group 0. Now this is a print statement, so this is not going to be going to Iolite's messaging main messaging thing. It's just going to be printed out to the Python console. So let's have a look at that now. So I'm going to open up my Python console, and we've got some stuff there already, so I'll just clear that. And now let's try importing our file. So we go file, import, and you can see it has printed our date timestamp. Now you can see it's printing some other stuff. This is sort of some debug stuff that comes with it. You can ignore that, but what I'm going to do is I'm just going to add to my script a couple of lines here, a couple of blank lines. So I'm going to print new line. That will just give us some space in our readout here. So if we clear this and we try importing our file again. Okay, so now we've got a little bit of space from those debug things. So it's printed out the line that it's found. That's great. All right, now what we want to do is we want to create a date time object from this string. Because remember, this is just a string. We don't know how many seconds since epoch this is, but we can do that now by converting it. So let's do that. So we'll add another, also we should add a comment here saying find timestamp. Okay, we'll get rid of this one now, and we'll say, we'll create a variable called start time. And we'll say that is equal to, so we're going to use the date time package, and we're going to use string parse time, and that's parse as in P-A-R-S-E. So it's going to be reading the parts of a string to make up this date time. And so what we do is we pass it the string. So our string in this case is match.group0. That's what was matched from our regex. And now we need to give it the format of our timestamp. So what we need to do is account for every part of our string here. And that includes anything that's not part of the date as well. So these characters here we'll have to explain, and we'll have to explain the leading and ending quote marks as well. So there's a few websites like this, but this is a nice succinct one, which is stringftime.org. Stringftime uses the same codes as string ptime, so we can use these here. But what it does is it gives you an example of things that you might find in a time string and how you can tell Python what parts that means. So for example, when we're trying to tell it that this part that we're looking at in particular is the hour as a 12-hour clock, we use the %i. So let's do that now for our string. So our string has this format here, and we're going to tell it now in a string here. We're going to tell it that the first part is the day. Oh, actually, sorry, we have a leading quote mark. Then we have %d for the day. Then we have a slash. Then we have a %m for the month. Then we have a slash. Then we have %Y for the year. Then we have this quote, comma, quote. Oops. Then we have the hour of the day. And when we go to this website, we're going to use, you have to be careful whether it's this H1, which has the leading 0, but this is 24-hour clock, or if it is this %I one, which also has a leading leading 0, but it's in a 12-hour clock. What I'm guessing from this is hard to tell from this one because it doesn't go past 12, but I'm guessing that from this PM that this is just a 12-hour clock time here. So we'll put in our script %I, then %M for the minutes, and then %S, and then we have a space, and then we have the AM PM part, which is %P, and we have a final trailing quote there as well. So let's write that. And if this works, we can print the start time. If it doesn't, we'll get an error message. So we'll clear this here, and we'll import our file again. And lo and behold, first go, we got our date time object. And we can tell that this is our date time object because it's actually put it in the ISO format, which is year, then month, then date, and so on and so forth. And it's actually using 24-hour time now. So this is actually, this shows that our process has worked. And just to show you why we're using this, we're actually using this so that we can get the second sense epoch. So let's do that by converting this to a timestamp. So in this sense, the timestamp is the second sense epoch. So now when we run this, so we'll clear this, open this, and you can see that we get our 1.5 billion seconds since epoch. So that is what we're actually going to use when we store our values, and we're going to add that value to each of the measurement times in our importer. Okay, so we've now got the time as a second sense epoch. So the next thing that we want to do is we'll want to go through our file and find where our data start. Now, quite often you can just say, all right, we've got 59 or 58 lines of header, and we're just going to cut those off. But if any of these data are left out for any particular file, then your importer will break. So if you're certain that these number of header are fixed, then you can just keep that value. Otherwise, you can do a little search for it. I'll show you how to do that now. Before we do that, I'm actually just going to break up our file data into a list of strings, and we can do that by saying file lines. This will be our list, and this will be file data dot split, and we're going to split it on every time there's a new line. So that will give us a list. Okay, and what we're actually working towards here is we're working towards this Pandas Read CSV function, which I'll just copy in so that you can see what values we need. Okay, so here's the function that we're going to be using. So we're going to create a data frame, and we're going to be doing it by calling Pandas Read _CSV. So it's going to take the file name, and it needs to know how many lines of data, how many lines to skip in the file before it starts loading in the data. So in our case, it's going to need to skip about 58 lines, around that number. We also need to tell it how many lines at the end to skip as well. We need to tell it also whether or not the first line that it reads, is that going to be the names of our channels, of our columns. And in this case, it's not going to be, because we don't have any column names. So we're going to put in none there. Instead, we're actually going to pass it a list of names. That's going to be the names list, and this engine equals Python part is just something that's needed to add as well. Don't have to worry about that bit. Okay, so we need to start working out how we're going to calculate some of these variables. So the first thing we're going to do is the skip rows, how many lines to skip to start off with. And we're going to do that just with a simple for loop. So we're going to say for line in file, I should call this file lines. So we're going to look at each line, and we're going to check to see if it has this spare text wording here, because we know that this is our last line before we get to our data. So we'll say if spare, got to get the case right, spare text in line, so that means that those characters are contained within that line, then we're going to stop searching. But we need to have some variable to find out where we're up to. So we'll call this first underscore line, and we'll say this equals 1 to start off with, because you'll skip at least one line. So if it hasn't found it so as it reads through the lines, then the first line, if it hasn't found it, we'll need to increment until it keeps going until it finds this spare text. So we'll say first line plus equals 1. So that'll keep incrementing until it finds this spare text. And we can check to see if that works by printing that out. So we can print f num of header lines, and then put in our curly braces and say first line. Okay, and we'll save that, and we'll run that. So we'll just clear this first, import our file. So it says 58, so we correctly found this. The other thing that we can do here is that we can find our sample name while we're at it as well. So if we've found our spare text and our sample name is always 2 lines before that, then we can just use list indexing to know that it's 2 items before this. So we can put that in by saying, we'll just get rid of this. This is just for debug. So we say samp, should we call it samp name? Yeah, let's call it samp name. Equals file for lines, and we're going to say it's first line minus 3. So we're going to actually go back 3 lines. And we'll just test that to make sure that works. So we'll print, here's the sample name, doesn't matter about the typo there, samp name, and we'll just check to make sure that works as well. and it has found it, so that's good. Spelling mistakes notwithstanding. Okay, so we have our sample name. So now we could also go through at this point and start pulling in metadata. We're just going to avoid that just for brevity because this is going to be a long enough video as it is. The other we could also look for footer lines as well, so we could keep searching through our lines to find where we get to the end, checking to see if we have numbers in each line, but we won't do that just yet. And now one of the other things we need in this line here, so we've got our first line here, we can create a footer lines here, footer underscore lines, and we're just going to say this is equal to 0 in this case because it does have one blank line but it won't actually read that. Don't have a header, and we need to create this names list. So in this case you just have to know what the names list is, but I'll just show you how I would do this for an isotope experiment, and I'm just going to copy these in. Okay, so I have I know from these data that the first column is actually strontium-89, the next column is strontium-88, so on and so forth. We have some half masses here which are important, and then when we get to the last part of it here, what we can see is we have a column that's just incrementing by 1 as each time we go down. That's just our measurement number. Not all files have that. These particular files do. We don't actually need it. We're not going to keep track of that at all, but we can use it for debugging a little bit later on. But we do need to name it so that Iolite will load all these files in, so all these columns in. The one after that is we have this this quoted number here, and that's actually the time elapsed. So this first measurement is associated with 1.1 seconds after our timestamp. Then the second line of measurements is 1.3 seconds after our start time, and so on and so forth. And this last line here is just it's just a value that's used by the new Plasma software that we're not actually going to use, but we'll still give it a name so that it'll load in properly. Otherwise Pandas won't know what to do with that column. So I've given all of my columns a name, including those ones at the end. So I've just called point number for the one that's just incrementing by 1. I've got time, and I've got this zeros column because it's just all zeros in this case. I've also created this mass list, which actually has the masses without the name in there as well. And that's important for isotope work where the mass might be called strontium-89, it might be called M89, it might be called M89.001, depending on your mass spectrometer. The new way in Iolite of actually finding which channel you want for isotope ratio work is that it'll actually look up for the mass. It'll look up the mass that it's after. And the mass is a property of the channel. So that's what we've got here, is we've just got these, and it only goes down to 81 because we don't have a value for these last ones here. Okay, so now we have our names list, and we have all the other bits of information that we need. We can now read in our data using Pandas. So we're going to say our data frame is equal to pd dot read underscore csv, and we're going to give it the file name, and we're going to tell it to skip rows. So the skip rows is equal to the first line variable. The next thing we're going to tell it is the skip footer, and we're going to tell it that's the footer lines variable. We're going to tell it that there is no header, so we're going to say header equals none, and we're also going to tell it what names to use to name the columns. So we're going to say names equals names list, and we're also just going to tell it to use the Python engine. That's just something you just have to put in. We're going to close the brackets there. Okay, and that is actually exactly this line that I pasted before. So I could have saved us some time there. Okay, and if that works, we should be able to print that data frame. So we'll clear this and we'll try importing our file again. Okay, so we've now created a data frame of our values. And when I say it's created a data frame, this is still just sitting in Python at this point. We haven't actually created any channels or anything in Iolite yet. This is really just getting it ready to put into Iolite. Now, luckily in this file format, we have this point number column, so we can check that we haven't cut off too many lines with our skip header number of lines to cut off. So if we can see the 1, the 2 and the 3, then that means we haven't cut off too many. If it started at 2 or at 3 or whatever, it means that we'd cut off some lines at start. And similarly at the bottom, we can check to make sure that it's reading all of our data, because it's a common error that I've found that sometimes you won't be reading all of your file by looking at the total number of points. So if we look in our file and scroll right down to the very bottom and have a look at this last number here, it's 26424, and we have 26424 here. If you don't have a point number column, you're probably going to have to actually check these values. So this last one here is 67091, 6709, and it doesn't actually print out all the values there. And same thing with the top. You might need to check to make sure that all these values actually make sense and that you have values for your chart or all of your columns. So that's now working. We now have a data frame, and just the way data frames are set up, each one of these columns is actually a NumPy array, which we can use to feed into our data manager. But before we do that, we need to convert this time column, which at the moment is still just elapsed seconds since the start of the file. We need to convert that to being seconds since epoch. And the way that we do that is by adding our start time. So let's do that now. And the way we do that is we say df time equals the current df time, but we're going to add a value to it, and that's going to be start time. And then after that, if we print data frame, we should see that this is now the seconds since epoch. Great, okay. So at this point, we could drop those columns for the point number and the zeros columns. So let's do that now. So to drop those other columns, I'm just going to, I've just copied and pasted a line of code that you can find on the internet, that I found on the internet really quickly, for dropping columns from data frames. So I'm actually just going to put a comment in here saying what we're doing. So we're dropping zeros column and point number. So the way it works is you pass it a list of column names that you want to drop. You have to tell it that we want to get rid of the columns rather than rows, and we've got this in place equals true part here, which just means that we're going to act on our data frame rather than a copy of our data frame. So now if we put in here our actual column names, so we change this to be let's first one point underscore number. Just got to make sure I got the case right for that. Point underscore number and zeros column. Okay, and then after we do that, we'll print our df just to check it. Okay, so now we just have our columns here. Along the left hand side here, it does have an index, which is like the label for our row. That's not actually a row. It doesn't have a heading there, so you don't have to worry about that. Otherwise, we have all these values here, and we can start feeding them into Iolite. So now we're actually going to create channels. So what we can do here is we're just going to use the named list to pass in each column at a time to Iolite. So we'll say for name in names list, I'm going to say data.add to input data. So we need to pass it the name, so we're going to say name, which is this variable here. We're going to pass it the column time, because that will return a NumPy array of our time values. Then we're going to pass it the name of our column, so our column of data. And we can put in here at the end a dictionary. And what we'll do here for this one is we'll just pass it this machine name, and we'll tell it that it is the new plasma instrument. Okay, so we'll just put a close bracket on that, and we'll give that a run. So clear that, and at this point, if we have added our channels correctly, we have I think that's supposed to be add data to input. Yes, I actually got the thing wrong. But once we start adding channels, we won't be able to just keep reusing the same experiment, as I'll show in just a sec. So let's go back here. So insert data to input. Okay, now let's give that a run. Okay, and we have a point number. Oh, okay. So I obviously didn't get rid of the point number column properly in this part here. So what have I done wrong there? Did I point number? Aha. I know what I did. So in my names list, I still have point number here, but when I go through this list here, I don't actually have a column called point number. So what I'll do is I'll actually just I'll remove them from our list as well. So we'll say names list dot remove, and we'll have to do this one at a time. Point underscore number, and copy that and do let's just copy what's in here. Okay, so we'll now get rid of those out of that list. So now we should actually be creating channels. And let's just see if it did create some channels. And yep, we did create some channels before, and it only bombed out when it got to the point number, etc. Okay, so we'll try this again, but now that we have channels, we can't just keep adding data to it because it'll actually report overlap errors. So we'll create a new session, and we'll open our Python console just in case there's any errors, and we'll say import file, and this time we didn't get any error messages. Go to channels, and we have all our channel data. Oh, we have time there. Okay, so we need to skip that on there, so we'll just put in an if statement. If name equals time, and we'll just continue. Okay, let's test that. Okay, now we don't have a time column, and we have these columns here. Now, one thing that I forgot to do was, if we look right at the bottom of our file, we didn't put in the blank value 1 millisecond after our last value. So we'll do that now. Oh, is that right? Oh yeah, that last channel is just all the 1 values. I'm not sure why that is, but I think that is actually correct. Okay, so now we need to add that blank value at the bottom of our data. And the way we do that is we add a column to our data frame. We'll do that before we add the channels here. So we need to do that. After we drop these channels here. So we'll do that here. And what we'll do is we'll use this line here, which is df is equal to itself after we've appended a series. So PD series. So this is basically just a blank row, empty series. We'll say ignore index equals true. Okay, so, and I'll just write what we're doing here. So we'll say add blank value to end of file, or to end of measurements. And then we'll set the time value for that to be 1 millisecond after our last time value. So we do that by saying df time is equal to, at the last point. So we access the last point by using iloc is equal to df time, so the time column at the second last point minus 2 plus 0.01. Okay. And now we should have a blank value added to the end of our channels. So we'll just do a quick new session and test that. Okay, so now when we go to our channels and we look at our raw data and we scroll all the way down, you can see that we now have a blank value at the end, but you can see that it looks like it has the exact same time value as the one before it. Now I tested this and it is actually just a floating point issue, which is a little bit hard to explain, but I'll just show you, demonstrate that it's not actually a problem here. So if we made this 2 milliseconds after, we save that and we run it again. And we look at our value right at the very bottom, you can see that it has actually added 2 milliseconds to the end. So in that other one, it's kind of a display error or a precision error, I guess you would say. Okay, so we've added that and we've created all our channels, and so now we're looking pretty good. But we want to actually add a little bit more information here. So we've managed to add the machine name, but if we look at some of these, you can see that just the way that the import process works, it thinks that even though this is strontium 86.5, it thinks the mass is 86 because it's trimmed off that 0.5 part. So we're now going to start adjusting some of the metadata about this channel. And the way that we do that is once we've added our data, we're going to actually get back that channel. So this function here doesn't return the channel itself at the moment. It may in the future. So we're actually going to get that channel back again, and we're going to store that as channel, and we're going to set some properties for it. So we can say channel set property. Let's set the units to start off with. Units. And for this, because it's a multi-collector, it's volts, and we'll just check that that works. So new session, now we have volts. We'll just check to make sure it's done it for all our channels. Yep, okay, so that's good. Now we want to put in the actual masses rather than this trimmed value here. And the way that we'll do that is we're going to use this mass list that we created before. So instead of looping through it, what I'm going to do is I'm actually going to combine these here. So I'm going to say zip names list, and so I'm going to make it so that it cycles through each of these at a time. And so we'll put mass list. So it's going to cycle through each of these values, and it's going to return the name and the mass from that. So then I can copy this, and we can set the property of mass to be change here to the mass. Okay, so we'll just give that a quick try. Okay, now when we go to our channels, if we go to one of these, you can see it's actually updated with the correct mass. Now we could keep doing this with other metadata as well, like the dwell time, or any particular parts, any other particular metadata we have about this particular channel. Notice this is working on each individual channel rather than working on all channels as well. So at this point, we've actually managed to import our data, but there's a couple of things that we haven't done yet, and that is there's no way for the user to know that the file has been loaded in this list of files here. So we want to create a file object, and we'll also want to create a sample object here. So we'll do that now. So to do that, we're going to use data.create file sample metadata. We're going to pass it the samp name, so the name of the sample. So this is actually this is a sample object, not the file object. We're going to pass it the start time. So we could pass it the start time, but remember that's in seconds, and it actually wants a date time object. So we're going to use date time from timestamp because it's in a timestamp format there. And then we're going to give it the end time as well. Now we need to get that last end value again, so we do that with date time from timestamp, and then we're going to pass it the last value in our data frame in the time column, .iloc -1. Okay, so that will give us the last value there, and we're also going to pass it the file name. So this is importer.filename, and we'll close the brackets there. Okay, so if we just quickly test that, and run it. So here's our actual sample object here. So that bit worked. Now let's look at creating our file object. So we do that by saying data.create imported file metadata, and we give it the start time. So again, date time dot from timestamp start time. We give it the end time from timestamp, and we give it the last value as well. So that's df time dot iloc -1 bracket. Then we're also going to be giving it the file name that was imported, so importer.file name. I could do this with better formatting. I'm going to give it the time that it was loaded, so we're just going to give it date time now. We're going to give it the number of data points that were loaded, and we can do that with df index. And we also need to give it the list of channels that were open, that were loaded. So we're going to call this our names list, and that should be everything it needs to create a file object. So let's give that a shot now. It's a new session, import file, and you can see we now have our file object, we have our sample object, and we have our channels. Now, one last thing is we'll just add some metadata to this file object. I know this video is getting a bit long already, but let's do that anyway. So let's create some metadata here. So I'm going to call this metadata, and I'm just going to make a string list here. So I'm going to say lens 1 and put a colon, and let's say that was at 1200, and it's going to be a comma separated list here. So we'll call this lens 2, and that was at 12. We'll say the vacuum was at -1 e to the -3. And that should just about do it, I think. So we'll put this in. Oh, sorry, I've put in typo there. Okay, so that's our comma separated list of metadata. And what we can do here is we can, this function returns the file object. So once we have the file object, we can set property. And we can tell it that the property we want to add is metadata, and we want to set it to the value of our metadata string list. And get rid of that statement. And so now when we reload that, so now if I say get our first file that we've loaded, so we say data.imported files, and we want the first one of those. Oops. That shouldn't have a 0 in it. Okay, so now we have our f value, so that's our file thing, and if we say show me the properties, it will have our metadata. And like I said, that metadata will stay associated with this particular file because that's where it got the metadata from, within this experiment. And then you can use it in your other Python modules if you want to extract this data some other way. So now we have created all the parts that we need from an import point of view, including metadata about channels and metadata about the file. And that data would then be fully accessible to all of Iolite's plotting functionality, and also data reduction schemes, etc. The last part of the importer is we're just going to let the user know that the import finished. We're going to set the progress indicator to be 100, and we're going to emit this signal saying that the process is finished. So that will be when Iolite updates things like this little plot down the bottom here, and also updates this table so that the user can see these here. And so that is actually an entire importer. So just to summarize what we did, we told Iolite via our accepted files function what file extensions we can import. We ran a check to make sure that this was the type of file that we wanted to import using this import module, using the correct format function. And then we actually imported the data, which included converting our measurement times to seconds and epoch. We got our channel names. In this case, we didn't extract them. We actually just typed them in, but you can extract them as well. We loaded our measurements as a data frame, and then we added our channel data using the add data to input function. We created a file object and a sample object, and that's all the things that you need to do in an importer. So with that said, let's talk about your assignment for week 1. This is just the first part. There'll also be a smaller second part to do, but basically you're going to write an importer for this brand new file type, which is from the IO Mega Synchrotron file. It has an extension of .iof. So this is the example data file for the assignment that you can download from the main course page. And to know if you're successful in your assignment, you will have written an importer that loads all of the data correctly. And by correctly, I mean it hasn't chopped any of the data off, it's labeled correctly, it has the associated metadata that you need to have with each channel. It will also create a file and a sample object, and you'll also get extra points if you include any metadata, and that will require you to look at some of the strings within the header data. So just like in the example that I gave today, it'll take a lot of it's an iterative process. You're testing each step along the way, and you'll be debugging when you come across problems. And so give it a shot. Always contact us if you get stuck, before you get frustrated. We can help you out before you start hitting your head against the desk. And actually, by the end of this, you will have written your first plugin, and you'll have that first step towards creating your own plugins for Iolite. So good luck, and let us know if you have any problems.